one main question to ask you guys. To prove triangle ABC is congruent to triangle DEF, as of right now, what things and how many different things would you have to prove? Now, with that in mind, draw yourself two triangles, label them accordingly that seem to be congruent. What is there to talk about? What things do you think we need to prove?
That A is congruent to D.
Okay. That this is congruent to this? So you're saying that angle A is congruent to angle D?
Yeah.
Does everybody agree with that?
Yep. Need to prove.
Noir, what else do you think we need to prove? Then shut up and pay attention. I'm sick of every day having to talk to you guys back there in that corner. Anyone else want to help them?
Angle B is congruent to angle E.
Angle B congruent to angle E. I like that idea.
Angle C and angle F.
Angle C congruent to angle F. Is that all?
No.
What else do you think we'd have to prove?
Segment
A, C,
AB.
and B.
We've dealt with all the angles, now we have to deal with probably the what?
Segments
Segment what?
AB is congruent to DE.
Segment BC is congruent to segment EF.
Segment BC, did you say?
Yeah.
Okay. It's congruent to segment EF. So we'll put 2 marks there. Anything else?
Segment AC is congruent to segment DF.
Are there any more parts you think we need to prove?
No.
So those are all the things. How many are there?
6.
6 different things. Three sets of what?
Angled.
Of angles. And what?
3 sets of segments.
3 three sets of, how about we say sides? Is that okay? Now, figuring triangles, you know, all the angles have to be 180, right? Add it up, have to add up to 180. And there's these things that have to be true about triangles. Wouldn't you think that if I had four or five of these true, wouldn't you probably bet you'd come to the conclusion they probably have to be congruent, right? Or maybe, probably not 4 or 5, 5 of 6, or maybe 4 of 6, or you know, you would think there's what? A shortcut. In other words, a combination of certain things would make the two congruent. Wouldn't you agree? Okay, it turns out there are a lot of combinations that actually do work. Okay? There are 4 combinations of sides and angles that work. Oh, combinations of 3 sides and angles that work. Sorry. So if we can prove 3 certain things congruent, I can say the 2 triangles are congruent. Hence, back to the title, what do you think SSS might mean?
Wait, so sides.
Show stupid.
3 combinations of angles and 3 sides.
There are 4 combinations of 3 sides and angles that work.
Steps.
Was I right?
What?
Side.
Absolutely.
Oh, yay.
And side angle
The
side.
first one we're going to learn is you'll always see it like this. And what it represents is side, side, side. If all 3 sets of corresponding sides are congruent, then the 2 triangles have to be what? Congruent. So over there on the side, draw yourself 3, and you'll get kind of in your mind that you'll get used to how these look. Side, side, side will look like this. You'll have this one congruent to that one, right? This one congruent to what? That one. And this one congruent to that one. That's what side, side, side will look like. If you can say that 2 sets of sides, or all 3 sets of sides, corresponding sides are congruent, then you can say this triangle is congruent to what? That triangle. You guys get what I'm saying? You know, there's 6 total things you can say are congruent, but it turns out that there's special combinations that work to say they're congruent. We can either have all the corresponding sides. If all the corresponding sides are congruent, then the 2 triangles are what? Congruent. We call that side, side, side. The other one.
Side angle side.
That one's pretty easy, isn't it?
Mhm.
Would you guys agree with that? The other one, and probably the hardest, is SAS,
Side angle
which
side.
is side, angle, side. You say, I can count the 2 sides congruent in one angle, right? Well, it's not that simple. What it says is if 2 sets of corresponding sides are congruent, and the sets of angles included, this is the by those two sides, are congruent, then the triangles are congruent. The key word here is the word included. You know, I often wonder why we picked that word. Let me make it bigger. What the math guys did. Maybe it's because this word could be interpreted in a lot of different ways, but I think of the word included as meaning in between. So included, if included means in between, I'm going to draw two triangles. I'll try to make them look like they're congruent, but I promise you they won't be perfect. Neither will they when you put them on your paper. When you copy. Everybody got that down where they can look up here now? Okay. Let's talk about side angle side. Now, here's what gives it away. And here's what will help you remember. What did I say? I said that included is the same as what? Anybody?
In between.
In between. When you look at the word SAS, why is everyone's eyes not up here? All I want you to do is look up here, because I'm trying to visually represent this. SAS. What would you characterize that A as being?
Angles.
In between.
She saw what I was trying to lead her to. I just talked about included meaning what? In between? Where did they put the A in between the two, or, yeah, I get late. Where did they put the A with respect to the two S's?
In between.
In between them, didn't they? That's why they call this SAS. Because it has to be, okay, if I had, let's say AB was congruent to DE, and BC was congruent to EF, what, if you were looking at that picture, what angle do you think is in between the two sides on the triangle on the left? B. Well, doesn't it make sense that B is the one in between these two?
Yes.
Because these two sides that are congruent actually make the angle B, don't they? Which one looks like it's in between over here?
E.
Guess what? This is side angle side. We'll draw another triangle. Remember, you can always watch, I'm not making you write these down. Remember, you can always watch this online. So I don't have to write this down in your notes. I'd rather you watch. Okay, because we'll just do a bunch of them, try to do a bunch of them really fast. Is that side angle side?
No.
No.
Or is this angle in between those two?
No.
No, it's not. that side angle side?
Yes.
No.
Wow.
Anybody tell me why?
Because
Because they're
the one on the left,
It is side angle side on the one on the left, is it not?
yes,
But isn't the angle in between them on the one on the right?
no.
It needs to be on both of them, not just one of them. So I tried to trick you there, didn't I? Is that side angle side?
Yes,
The one in between them, isn't it?
yes.
You see how it's kind of easy once you get it? Is that side angle side?
No,
It isn't, is it?
no.
Does anybody know, how would you characterize that?
Angle side side.
Angle, side, side. What?
I don't know.
The one that makes a cuss word doesn't work. And don't ever tell me to, it's not okay to say, you're being an angle side side today, Coach. Okay? That's not acceptable either.
I can use that at work.
And yes, I had a dodgeball team that wanted to be named angle side side.
I'm doing that. That's what Mr. Halls is going to be, angle side side.
Anyhow, point I'm making is it's funny how everybody loves this lecture and everybody always remembers that the one that doesn't work is angle side side. There's two that don't work. Basically,
Side side angle.
SSS works.
Side side.
SAS works. Angle side angle works, which we'll do, Monday. Okay? And angle angle side works. Those are the four that do work. The two that don't is the one that makes the cuss word, and then you can think of the one that's three of the cuss words. Okay? Or those are the two that don't work. Or I'd say the one that makes a cuss word and the one that should always be a good thing, getting 3 A's, right? And in this case,
You could just
bad
apply
thing,
card-
doesn't work.
card insurance.
Angle, angle, angle does not work, and angle, side, side does not work. But these all do. And what do you think this is? If you were guessing what we're going to do on Monday, I want to see how many of you will get this. Right?
Angle, side, angle.
It'd be two angles, and how do you think this side relates to the other two angles?
Like
It's in
It's
between.
the one
in between the
in
angles.
between.
Yeah.
No
How about
way.
this one?
Fire.
Two angles, and then the one what?
Side side.
Not what?
In the middle.
In between.
between.
But as you can see, the concept of this isn't too bad, is it?
No.
Once you understand what included means. That sounds weird to everybody. But just remember, and there's lots of ways you can do this. If I was to walk, here's one way to test it too. If I was to walk from one side congruent directly, the fastest way to the other side congruent, which way would I have to go? Towards A or towards B? Towards B, and then I'd get over here to that one, wouldn't I? You'll always cross over the angle that's what? Included. Agreed? Angle, side, angle. Or I'm sorry, side, angle, side. If ever you start here and you went to here to go towards the angle, side, side, and then angle, you see what I'm saying? If it was this one, if you look over here, that helps some people it doesn't, but this one didn't work, right? It didn't work right here. Because if I started at this side, and I walked to the angle that's congruent, would the next thing I got to be the other side that's congruent? No. So it's not side, angle, side, because it's side, angle, skip a side, then side, right? However, every time that it works, this one worked, didn't it? You went from the side, then you get to the what next? The angle, and then you get to the what? Side, then you got to the what? Angle, and then you got to the side. The one that didn't work here, you started at a side, you got to the angle, then you didn't get to what? You got to an angle next. You had to skip a side. You had to go all the way over there to get to the other side. See how that doesn't work? You had to take a long way around? I don't know. It helps some people it doesn't. But you guys understand the difference between included and not included. It's pretty easy. Okay? All right. We'll leave it at that. Maybe do some more examples tomorrow.